We didn't hear it, so don't. Yeah, what?
Share. Okay, so it's recording. And are you getting the picture now?
Yes.
Okay. Got the funny half of a textbook picture.
Yes.
Okay, you'll be pleased to know I'm still as addicted to coffee as always. Right. Except now I get decent coffee, not crappy starving coffee. Right, let's do this. Number 2. Number 3 on page, so we're on page 185. Okay. And it says to us, the heights of teenagers in Johannesburg are considered to be normally distributed with a mean of 164 centimeters and a standard deviation of 18.5 centimeters. At a theme park, teenagers below the lowest 4% of height and also above the highest 0.5% of heights cannot get onto a certain thrill ride. Okay, A, what is the minimum teenager height to be allowed on the ride? Okay, so if we look over here, we've got, can you all see? Okay, who am I going to talk to? I'm going to pick on somebody, right? Hannah, I'm picking on you, and I'll just pick on you for this first part of the sum. Are you with me, Hannah?
Yeah.
Unlucky. Get it out the way. So, and stop me if I make, the rest of you just shout out if I make a mistake. So the mean, always do a little summary. The mean is 164 of their heights. The standard deviation is 18.5 centimeters. And below, the shorties below 4% can't get on the ride. Oh, shame, man. Okay, right. And the very tallies, no names mentioned, also can't get on the ride. Okay, right. So below 4%. So the first question is, what is the minimum height that a teenager can be? Okay, so my understanding, and as I say, if you disagree, let me know. I don't like to work from the memo. Okay, so let's start off, and we're going to have X scores and Z scores, and the mean, fill that in, of teenage heights is 164. Okay, and the Z score that goes with that is 0. Now we want to know what's the minimum height. Okay, and the minimum height is going to be somewhere over there, and what this area over here, the people below that height can't get on the ride. Am I right? So that's going to be 4%. Okay, and in probability terms, that's 0.04. So if you are, if we call that Z score over there A, that's our Z score, okay, at that point over there. Okay, if you, that's your minimum height you can be in order to get on the ride, because the 4% of people are discriminated against and they can't get onto the ride. Okay, they should start a petition. Do you agree with that, Hannah? Does that make sense?
Yes, sir.
Okay, so now what are we going to have to look up? We're going to have to look up the area, and can I look up that area, Hannah?
Yes.
No, the answer was no, Hannah.
No.
You're going to have to look up. Remember, your table gives you the green area. Okay.
Oh, yes.
Always between the mean and a score. Okay. So what is this green area going to be?
0.5 minus 0.04.
Good. Which is going to be 0, what's that? 0, what's that? How can I not do that in my head? Maybe it's Friday. 0.46. 0.46. Yes. Thank you. Okay. So that's 0.46, right? So that's the area I'm going to look up. Okay. And that's going to give me, and then I'm going to make, remember, this is a negative Z score though. Okay. This value has to be negative because it's to the left, okay, of the mean. So you're going to go to your tables, okay, and we're going to go look up 0.46, and 0.46, where is it hiding? Yeah, that's pretty close, darn close to it. So that's 0.4599. So it's going to be 1.75. Happy with that, Hannah?
Yes.
4599. Okay, so this Z score over here And remember, the table only gives us the area to the right. So it's giving us the positive z-score. So we need to just make that negative because of symmetry. So it's going to be negative 1,75. So A is going to be negative 1,75 in this scenario over here. And that's your z-score is negative 1,75. So in other words, the bottom 4% will be 1,75 standard deviations to the left of the mean. And now you need to go find the corresponding x-score. Okay, these over here are z-scores. We need to now use that to figure out what is 1,75 standard deviations to the left if my mean is 164 and my standard deviation is 18,5. Okay, so Hannah, what are we going to use to convert from a z-score to an x-score? There's that formula. Can you remember it?
Z is equal to x minus mu over sigma.
That's it. Okay. Z is equal to x minus mu over sigma. Okay. And we're looking for x. So I prefer to manipulate the formula. So it's going to be z sigma times it out plus mu is equal to x. And now we put in our values. And what is our z-score? Our z-score is negative 1,75. The standard deviation is 18,5. And the mean is 164. And that's going to be the minimum height to get onto this ride. So I'm going to go negative 1.75. Okay, what's it? Negative 1.75 times 18.5 plus 164. And I got 131,6. I don't know, did they specify decimal places? Okay, 131,6 centimeters, let's just say. So the question was, what's the minimum height? Well, if they're measuring you, it's going to be approximately 132. You have to be at least 132 centimeters to get on the ride. So if you know your height, okay, ask yourself, will I get on the ride? Is it worth my while to head off and go on a thrill ride? Right, let's just check on the memo if we're right. Hannah, did you agree with that?
Yes.
Look right. Anything obvious? Anyone else spot any obvious mistakes? And let me check the memo. We are absolutely right. The minimum height is 131,625 centimeters. Okay, so what's the procedure? Draw a diagram. Okay, sometimes it's reading the English part of the question, which is kind of the trickiest bit. Right, so that was question 3A. 3B, any volunteers? Thank you, Hannah, for your participation. No volunteers? Caitlin, are you around? Oh,
Yes,
it's so
sir.
nice to be. Oh, it's well done because I actually can't see who's here and who's not on the screen. So brave to not to just keep quiet. So 3B says to us, what is a maximum teenager height to be allowed on the ride? I remember with maximum, what did they say? If you're above the top 0.5%, okay, boom, no ride for you. Okay, Morgan, we're going to check if you'll be able to make this ride. Okay, so we know once again that your mean is 164 centimeters. Okay, and your standard deviation, what was it? 18,5, eh? 18,5 centimeters. Okay, so let's start off by drawing a diagram. Okay, we're going to look at z-scores, we're going to look at x-scores. Okay, and our mean, sorry, my x-scores are below this time. My mean x-score is 164, which goes with a z-score of 0. And right, what are we looking for? Okay, you can't get in if you're above a tiny portion of tallies won't be able to get in, and it's the people sitting in that little area over there. And so this area here is 0.5%, eh? And 0.5% divided by 0.5 divided by 100 is, what's it, 0.005, eh? Am I right? Okay, Friday afternoon brain. Okay. Yeah, 0.5, 0, yeah. Caitlin, does that make sense?
Yes, sir.
Okay, so that area is 0.05. So these are the people that are in the top 0.5%. Okay, and they're not going to be let in. Okay, so this is, we're looking for a Z-score. I'm going to call that Z-score A. Okay, and we need to go figure out that Z-score. What I have to do in order to use the table, Caitlin, to figure out what I have to work out, what value I'm going to use on the table.
You have to work out that.
Okay, so what's this one going to be?
It's going to be 0.5 minus 0.005.
Yep. Okay, and if we gooi that into our calculator, we get 0.5 minus 0.005. Okay. And you get 0, sorry, I can't do any mental arithmetic today. 0.495. Right, so this area over here, okay, is the area we're going to look up. And that area there is 0.495. Okay, so everyone go to your table and let's see if we can reach an agreement on what Z-score goes with 0.495. Okay, so I go to my table, okay, and go try to find it. Where are you hiding? 0.49. Well, there's 0.49506, and this is 0.4942. So that's about, it really doesn't matter, those values are so small. Okay, I mean, strictly, we could go in the middle if you want with that one, because that's whatever that is, 8/10 thousandths away. What's it, 0.49? 0.495, eh? Yeah, so 0.495. Quite honestly, once again, if you use that Z-score over here of 2.5, if you use 2.57 or 2.58, it'd be absolutely fine. I'm going to go in the middle, so it'll be 2.575 is in the middle. Am I right? Does it look right, Caitlin?
Yes, sir.
Okay, so as I say, if you use 2.57 or 2.58 to be fine, I'm going to get fancy and use 2.575. So the Z-score that goes here, so we're going to say that A is equal to 2.575. We want to use the right notation. I could say, what could I say? H of 2.575. If you don't write it like this, it's not the end of the world. Okay, so that means the area to the left of 2.575, okay, is equal to, what was that area? 0.495. 0.495. Therefore, the probability that, okay, don't worry about it. Okay, I'm bogging myself down with technicalities here. So this Z-score over here is 2.575, which means that if you're going to be in the top 0.5% of tall teenagers, you're about 2.6 standard deviations to the right, bigger than the mean. Okay, so now we've got our Z-score, which is 2.575. So how are we going to find our X-score, Caitlin?
You go.
Other way around,
X
sorry.
is-
Z is equal to?
Z is equal to X minus mu over standard deviation.
Yeah, so Z sigma plus mu is equal to X. Right, so go shove your values in, everyone, and go figure out X.
211.
Let's have it. Okay, go for it, Morgan. What do you say it is?
211, 211.64.
Okay, let me check. No trust, I'm afraid, Morgan. Carry on as we were pre-lockdown. What did I do?
Oh, think about the answer. Yeah.
201.64, did you get?
Look who's right. Cycle waves.
Did you say that? 201.64. Caitlin, did you get that?
Yes.
Okay. So, sure, you're a pretty tall teenager. Morgan, you're going to be able to go on the ride, you'll be pleased to know. Okay. 211.64 centimeters. If you're above that, you ain't going on any ride. But I'm yet to see many people above that height. Okay, let's just check in the memo if we're right. Yes, we're right. Okay, they used the Z-score of 2.58, but ours is actually more accurate. Okay, 211.64 centimeters you have to be in order to get onto the ride. Okay, righty, we're getting there. Any questions about that one, guys?
Yes. If we weren't to if we didn't go in the middle, would it be wrong? Would you mark it wrong or?
What do you mean?
If we
Oh
didn't
no, that's what I was saying. No, if you used Morgan, these values are so small. I mean, you're looking at the 4th decimal here that you're comparing to. So if you had used 2.58 or 2.57 and didn't go in the middle, it would be fine.
Okay. And would it be like that for all of them? So we don't.
Yeah, I'd be very surprised if they penalized you. I certainly wouldn't. I mean, maybe there's some which are pretty obvious, like when you get high up here and then you're working with less decimal digits. So say you had, if you look at this top row where I'm pointing, if you had 0, an area of 0, I mean, it goes from 0.23 to 0.27. So if you had like 0.25, then you should really kind of look to go in the middle. But honestly, I don't want you to waste time spending hours on that. If you use either one, generally if you use the one that's closest, that's absolutely fine. Does that answer your question, Morgan?
Does indeed, sir.
Who's in your photo, by the way?
Sasha and Chloe. It was taken at camp, I think, a year ago or something.
Oh, back in the day when you were allowed out the house, eh? Right. Let's have a look. The next one we're supposed to do is question 4, I think we said we'd do. Okay. So question 4. Well, Morgan, seeing you on the line, you are going to be our volunteer. Okay. A forced volunteer. And question 4. Right, let's do a little summary of this chap. Question 4 says, okay, in a telephonic call center, a typical agent averages 68 phone calls per day. So phone calls per day. As I say, sometimes the reading the thing out, getting the English right is exhausting for illiterates like me. Okay, so the average is they get 68 phone calls a day, and their standard deviation is 8. The amount of calls is found to have a normal distribution. That's harsh. Management decides to fire all agents who are in the bottom 7.5% of call performance. Okay. Oh, they call. Shame, I thought they were just receiving. Okay. Bottom 7.5% of call performance. What is the cutoff for firing an agent in terms of average calls per day? Right, Morgan, so you are sitting here, you're doing the sum. What would you do first?
The diagram.
Lovely stuff. You draw a diagram and focus that brain and say, all right, I'm going to have, I don't know, Z scores and X scores. What's the Z score at the mean, Morgan? It's 0. Okay, and the X score is, the mean is 68. Okay. Right, now who's going to get the chop? The bottom 7.5%. So the people that are in the bottom bits, they are getting the boot. And that area, who gets the boot? Probability of getting the boot is 7.5%, which is 0.7 0.075. I've moved that 2 to the left. So that's the area who gets the chop. Morgan, am I going to use 0.075 on the table?
No.
No. What am I going to use? I'm going to use the yellow region. How do I find that area?
0.5.
Yes.
0.075.
Okay, so that area is 0.5 minus 0.075.
0.425.
Which is 0.425. Right. So Morgan, okay, you're going to look up, just remind yourself the z-score we're going to call A, and that has to be a negative number, right? Because it's to the left. Right, so I want you to please be so kind as to go look up 0.425 on your table and tell me what you get, and we'll see whether we concur. Hang on, 0.425. Well, here, Morgan, go with that one, Shirley. No, I'm speaking absolute hogwash. This one here, eh?
Yeah.
0.4251. I mean, it's just about 0.425. So there we certainly don't have to worry about it being in the middle. And what is that z-score, Morgan?
1.44.
1.44. You are representing the north very well. Okay, 1.44. So and it's going to be negative, eh? So the z-score we're working with is A is equal to negative 1.44, right? We looked at the probability that Z was less than A was 0.075, right? So A is equal to negative 1.44. What we're going to use now, Morgan, to figure out who's getting fired, how many calls.
X
Yeah.
is equal to negative 1.44 times 8 plus 68.
Okay, let's have a look. So tell me what you get as an answer once you've done it.
56.48.
So then let me, oh, you're ahead of me. Z is equal to negative 1.44 times sigma. Sigma was sigma 8. Yeah.
8.
Plus the mean. And the mean was 68. And 8 times negative 1.44. What did you say the answer was, Morgan?
56.48.
Oh, fantastic. High five yourself, Morgan. So basically, good. First high five I've heard in a while. Okay, you're going to get fired if you're probably getting 56 calls a day. Making 56 calls a day. Boom, you're gone. Okay. Right. Thank you, Morgan. Morgan, I can't see who's on this call. Would you like to pick somebody?
Bianca's on this call.
Bianca, welcome. Shame. Second time today, Bianca. Are you there or are you hiding?
Coffee, sir.
Sorry?
I brought coffee like you told me to.
Oh, good. Good. You must. Did you bring cake?
I can. I have cake downstairs.
Just to the whole group. Would anyone like to confess that they're still in their pajamas?
Me, I'm still in my pajamas.
Huh? Morgan, well done.
I shower and get into new pajamas.
But you haven't been in your pajamas for the whole week, have you?
I have, because I shower and then get into new pajamas.
Oh, okay. It's not the same pair. It's not the same pair the whole week. Okay. As long as it's not the same pair, we'll accept that.
Yeah.
Right. Let's have Bianca. Let's have a look at question 6. Question 6 says, Dr. Johnson's research stated that during sleep, the reduction of a person's oxygen consumption, has a normal distribution of 38,4 with a mean of, so the mean of how much they, I didn't realize that I suppose we do consume less. Mean oxygen, so we're looking at oxygen, consumption, as an oxygen consumption reduction. We don't have to write that down. Just like to know what's going on. Okay, so how much less oxygen you use when you sleep has a mean of 38,4 milliliters per minute. Sure, we would have thought. Right, and a standard deviation of 4,6 milliliters per minute. Okay. It says, determine the probability that during sleep a person's oxygen consumption will be reduced to anywhere from 30 to 40 milliliters per minute. So, Bianca, even if you don't know what's going on, okay, how are you going to start the question?
Draw a graph.
Draw a graph, that's it. Okay. And then this helps to focus your mind. And we're going to have, I'm going to put X scores at the top this time and Z scores at the bottom. Okay. And we've got a mean X score of 38,4, which coincides with the Z score of 0, because the Z score is how many standard deviations you're away from the mean. Okay, now they say to us, what do they say to us? They want to know the probability. So we're looking for probability this time. Now be careful, guys. Up to now, we've been given the probability. Now we're looking for probability. They're mixing it up a bit now. Okay, so they want to know that what's the probability that you'll be between 30 and 40? Okay, that you'll have that oxygen reduction between 30 and 40. So we're looking for an area now. We're looking for that yellow area, because that's, remember, the area, that's your probability that X lies between 30 and 40. So we're going to try to find that area over there. Okay, and at the moment, I just know the X scores. So in order to find the area, I'm going to first have to find the Z score that goes with 30 and the Z score that goes with 40. Okay, right. So if we have a look at X is equal to 30 and X is equal to 40, okay. Bianca, what's our formula we're going to use to find a Z score?
Z equals X minus the mean over standard deviation.
Good. Okay, so let's go chuck those in. Okay, and we get X was 30, mu is 38,4, and standard deviation is 4,6. All right, so go work that out.
Negative
Did you get my-
1.826086.
Okay, so negative 1,826. Now remember, when we're looking at Z scores, okay, we can only do it to 2 decimal place. So let's make it negative 1,83, hey? Negative 1,83. So this Z score here is negative 1,83. Okay. Okay, and then with X is equal to 40, we're going to get Z is equal to 40 minus 38,4 over 4,6. All right.
Negative
And
2.17.
what did you get, Bianca?
Negative 2.17.
Hang on, it's
Wait,
40 minus 38.4. Okay, so it's going to be, I got 0,35. 40 minus 38,4 over 4,6. Did anyone else get 0,35?
I did so.
Okay, just check that, Bianca. Okay.
Yeah.
Right, so I got Z is equal to 0,35 there. Okay, right, now, okay, I've got those two things over there. Now I need to figure out areas. So first of all, let's go figure out, okay, we're going to have to do them separately. The area, this pink area is probably the most, that one I can read straight off, there's no complications at all. In fact, both we can. So I'm going to go look up a Z score, okay, to find the area. Remember, I'm looking for the area, I'm looking for probability. I'm going to go look up a Z score of 0.35, a Z score, eh? So I'm working at the sides, I'm not working with the area, I'm working with the Z score, and I'm looking for a Z score of 0.35. So there's 0.3, there's 5, 0.35. Okay, I got that. Does that make sense, Bianca?
Yes.
The rest of you get that? Did you get 0.1368?
Yes.
Okay, great. So for this to do with the 40, the probability that X lies, we worked out between 0, and you don't have to write this down necessarily. You can just, I'm honestly not going to penalize if you write things on the diagram. Okay, so this area here we said was 0.1368. So the probability of that X lies between 38,4, I'm looking at X scores, and 40 is 0.1368. So that's that pink area over there. Okay, to find this leftover yellow area, okay, you're going to have to look up a Z score of positive 1.83. Okay, because of symmetry, I can use 1.83. That diagram's not symmetrical, by the way. Okay, this should be more to the left. Okay, so I'm going to look up a Z score of 1.83, and 1.83, what does that give us? 1.8 is there, 3 is there, 1.83. Did you guys get 0.4664?
Yes. Yes.
Okay, you get that. Okay, so I get here, this yellow area over here is 0.4664. Okay, so this area here is 0.1368. This area over here is 0.4644. And the question is, okay, so if you wanted to write it down, you could say the probability that X is bigger than 30 and less than 38,4 is equal to 0.4664. So the total final answer, sorry, I'm going off the page, okay, that we're looking for. So how am I going to find the whole shaded region?
You add the two together.
Add the two together, right? So the probability that X lies between 30, good, and 40 is going to be 0.4664 plus 0.1368. And I got, you get 0.6032.
Yes.
Okay, so about 60.32% of people, what are they doing? They have oxygen consumption, blah, blah, blah. Okay, oxygen consumption decrease of between 30 and 40. Okay, let me check in the memo that we got that right. That's a question. 6, eh? 6. Yep, we did right. 0.6032. 60% of people lie in that region. All right. Well, if you want to go, you can go. I'm just going to finish 6B. Okay. All right, but there is 6A. And it's quite nice because these are past final paper questions. So it gives you an idea of what's going on. Haley, are you still around?
Yes, sir.
Okay, let's give 6B a go. All right, 6B says the following. Okay, 6B says, okay, so let's just write down what we've got again. We've got a mean of what? Our mean oxygen decrease was 38.4 milliliters per minute, and our standard deviation was 4.6 milliliters per minute. Okay. Now it says, if 90% of people reduce their oxygen consumption by more than K, this is where I can go mad. Okay, let's have a look. Okay, let's just start off. If 90% of people reduce their oxygen consumption by more than K milliliters per minute, determine K. Am I right in saying 90% of people reduce their oxygen I've done this the wrong way around, haven't I? Okay, because this is our reduction in oxygen. Okay, and if 90% of people reduce their oxygen consumption by more than K, I'm going mad. 90% reduce their oxygen consumption by more than K. Am I to the left or to the right? So if I had K over there, then yeah, I am right, I think, eh? Would this be 90%? Would that be right, guys? All of you can chip in here. I'll check in the memo now. But if 90% reduce by more than K, no, I've got it the wrong way around, I think. By more than K, determine K. Yeah, it's going to be the wrong way around because 90% K is going to be over there. 90% are more than K. Yeah, so K will be to the left. Would you agree with that?
I don't like English, so.
Anyone else? Okay, I think that's what that means. Okay, if 90% of people reduce it by more than K. Okay, it's a rough question to get this time on Friday. Let's just check. I think I'm right. We're doing 6B, eh? Yeah, I'm right. Okay, quite difficult English that, but we're also tired. Okay, so this area is 90%, so it's going to be to the left of the mean, because 90%, this is the oxygen reduction, right? X represents, the X scale is the oxygen reduction, and 90% have reduced it by more than that value K. Okay, I don't know why that took me such a long time to figure out. Okay, but that is what it's going to be. Okay, I hope that makes some kind of sense. 90% is the area bigger than K. So in other words, the probability, what they told us, I should have just started like this, the probability that X is greater than K is equal to 90%, which is 0.9. Okay, so if I go back here, let's go back and fill some values in. The mean is 38.4. Okay, our Z score there is 0. Here is K chilling over here. Okay, and now the question becomes, I find that first step, reading that, often the most tricky thing. Okay, so the probability that X is bigger than K is 90%. Go figure out K, which is K is just an X score. Okay, so the first thing I'm going to have to do, now I'm given the area. Okay, so I'm given area, and my strategy is going to be, if I'm given the area, I have to find the Z score, and then I have to use the formula to find the X score. Okay, remember this K is going to be a negative number, eh? Because it's to the left. So, Haley, do I look up 0.9, which is the whole yellow region?
No,
No, what are you going to look up?
just negative 0.4.
Yeah, well, not Z negative, it's an area, eh? So it's just 0.4. So I'm going to look up an area. I'm going to go 0.9. So the probability that X is bigger than K, less than 0, is going to be 0.9 minus 0.5. I'm chopping out the yellow bit in order to get the green bit, which is 0.4. Okay, so I'm going to look up the area now, not the Z score. Okay, always focus your mind. You've got probabilities in the middle. So go find an area of 0.4 and then the corresponding Z score that goes with it. Tell me what you think you get, Haley.
1.285.
No, yeah, I'd actually go with 1.28. Okay? But if you did 1.28, I wouldn't be wrong, because 9997 is 0.00. It's only 3 away, whereas this one's 15 away. Does that make sense?
Oh yeah, okay.
Okay, so I'd go with this one over here. So I'd go with just 1.28. Okay. You happy with that?
Yeah.
Okay, so in other words, okay, K is equal to, what did we say? Negative 1.28, eh?
Yeah.
Okay, so K is equal to negative 1.28. Okay. So that's my Z score, eh? So my Z score K is negative 1.28. So I've done this thing. I've got the Z score. Okay. Now I've got to find the x score. How am I going to do that?
With the formula.
Yep. Okay, so go for it. Z sigma plus mu is equal to x. And our z score was -1,28. And what's the sigma? 4,6 plus mu, which is 38,4. It's going to be our x score. And sorry, I'm speaking why am I speaking cut, guys? Sorry, bad language. Why am I speaking nonsense? K is an x score, not a z score. Sorry. So just go have a look at your diagram again. I should have called the z score. I don't know k yet. I'm going to call my z score that goes with ka. So a was negative. The z score was -1,28. Sorry. The z score was -1,28. Okay. The x score for k, I don't know yet. That's what I'm trying to work out here. Okay. This particular the x score we're looking for, so this was a, sorry, was -1,28. Okay. And this x score is k. So k is the x score that goes with a z score of -1,28. Has anyone worked that out?
I think it's 32,51.
Yeah.
-1,28 times 4.6 plus 38.4. It sounds right. And what did you say? 32,51.
Yeah.
Okay. And milliliters per minute. So 90% of people will decrease by more than 32,512. Let's check our answer. 6B. 6B. Yep, we are absolutely correct. Okay. Guys, I don't know about you, but I'm whacked. Okay. There are a couple more you can try on your own if you want. Like maybe try 7 and 8. That should be enough. If you want to do more, if you're super keen, you're welcome to. But maybe go have a nap.
Thanks, sir.
Okay, guys.
Thank you, sir.
Remember, if you've got questions, you're welcome to send them anytime. Okay.
Thanks, sir.
Also,
Okay.
just a question in general.
Yeah.
Will only like half of the teachers be able to come back to school?
It's a good question. I think last I heard yesterday, because I asked that same question, I was like, well, what worries me is that, you know, there's a whole lot of teachers missing, that matrics might think it's not worthwhile to come back to school, which I could almost understand. But the reply I got was that they're not making it, but don't quote me on this, please. Okay, that people, if they're going to, apparently if you're older than 60, whatever it is, and your doctor says you're healthy, then you can come in. So at this stage, Hayley, I can't really answer that question, but I think a lot of the teachers older than 60 want to come in, but I can't confirm yet whether or not they're going to be allowed to come in.
Because isn't that like half of our teachers? Because Radine likes to keep.
Not me, eh?
Not you, sir. I know, not you. But
Hayley, they'll confirm it, I'm sure.
okay.
But yeah, I think the teachers want to come in. The question, I think, is we're not quite sure yet exactly if they're going to be allowed to come in. How are you feeling about coming back to school? I'm just going to stop recording.
I'm very.
But it kind of sucks at the same time because like all our privileges, like we don't really get like the studies, we won't get that.
Yeah, I know, guys. That is I mean, I have to admit, we had a HOD meeting the other day,